Next is the shortest route problem. In here we have a network. We have a starting point and an ending point connected through a network of nodes and arcs, and we want to determine what is the shortest route possible from the starting location to the ending location. So it'll be like you have a transportation network. You want to find what is the shortest path from one point A to point B. Okay, so here we have the plant, and these are the intermediate points, and then we have the warehouse. So each arc, the number that is associated with the arc is the distance. Now we want to know what is the shortest path from 1 to 6. So what we're going to do is we're going to set the supply at the plant to equal 1 and the demand for warehouse equal to 1, and all of these will be treated as transshipment point. So if that 1 comes in, that 1 has to go out, and then we just do a sum product of the flows with these distances, and that will give us the shortest route. So let's head on over to Excel. Okay, so here is the network. So let's first transfer all these numbers into a matrix from node the to node. Okay, so 1 to 2 is 100, 1 to 3 is 200, 2 to 3, okay, and this is a symmetric matrix. Okay, so the distance between 1 to 2 and 2 to 1 is so 2 to 3 is 50 and 3 to 2 is 50. So 2 to 3, 3 to 2. Okay. Similarly 2 to 4, 4 to 2, 2 to 4. Okay. But for 1 and 6 you won't do the other way around, because from 1 the 1 is planned, so it's not a transshipment point. The supply of 1 can only go out, it cannot come back in, whereas in all the other nodes you can have like in 3 from 2 the flow can go from 2 to 3 or 3 to 2. So that's the reason why for all the transshipment points you have to code both direction of the arcs. Okay, let's format these. Okay. Now once again we have to enter all the origin and destinations. So origin from 1 you have 2 and 3. Okay, for 2 we have 3, 4 and 5. Okay, so for 2, so there is no 2 to 1. Okay, so you have only these 3, 2, 3, 4 and 5. And for 3 we have, okay, no 1, but 3 to 2, 3 to 5. And for 4 you have 4 to 2, 5 and 6. Then you have 5. Okay, 5 is 2, 3, 4 and 6. 4 and 6. 5, 2, 3, 4 and 6. Alright, so now let's get the distances, and we can use index now. Index of the array, so which is that F4. Then the row number and column number. Let's align these. Okay, distances. All right, so the flow is our changing cell. Okay, so we have these 6 nodes. Right. And the net flow, okay, so net flow is going to be sum if, okay, we can do this in a couple of different ways, but I'm going to do it in one way that is the same for all the nodes. So we will look at origin first and then destination. So range is origin, okay, comma the node, comma flow. Okay, press F4. So that is what is going out. So now we are using origin as the lookup range. So what is going out minus what is coming in, sum if. I know that there is nothing coming into node 1, but if we set it up in this way, we can just copy the same formula for all the nodes. Sum if destination. So now what is coming in, press F4, and the node and the flow. Flow is F4 again. So what is going out minus what is coming in. Okay, so here that should be equal to 1. What is going out minus what is coming in, that should be equal to 1. So now since we set this up as a net flow, we can copy that all the way around. So for all the transshipment points as well. For all the transshipment points, this will be 0. Now for the destination, since we've set this up as what is going out minus what is coming in, so nothing is going out of 6. 6 is the end point. So nothing is going out minus what is coming in, so 1 has to come in, so this should be equal to minus 1. Then we do a sum product of the distance and flow. This will be the total distance. This is not flow. Total distance from 1 to 6. Okay. So we can run solver now. Want to minimize that. I have to color code that. I'll do it in just a second. That's our flow. Add. And once again, because we set this up in this fashion, we can just enter the whole thing as just one batch of constraints. Okay. Non-negative simplex LP. Solve. Okay, so color code this properly. So the shortest distance is, okay, wherever there is a flow, that's the arc that we are taking. So this is arc 1 to 2 is taken, and then 2 to 3 is taken, and then 3 to 5 is taken, and 5 to 6. So 1 to 2, 2 to 3, so 1 to 2, 2 to 3, 3 to 5. Okay, so like that, like that, like that, like that. Okay, so that's the shortest distance of 290.